2/7. 2/7/24, 1 week before Valentine's Day and Ash Wednesday. If you don't know what Ash Wednesday is, don't ask.
What is Ash?
I shouldn't have said that. It's a religious kind of holiday thing. So, look it up. Google it sometime. All right, sketch a parabola with no real roots. What is this going to look like if I don't have any real roots? Andy, please put that away. I really don't want to have to see it out again. I feel like it's out a lot. What's this going to look like with no real roots? Anyone? What do you think, Ariane? Right, it's not going to cross the x-axis. So you can have, something like this. You can have something like this. All right. Maybe a little something like this. Okay. Maybe you have something like this. All right. But it's not going to cross or intersect or touch, cross or intersect or even touch or bounce the x-axis. Okay? Did anybody happen to draw something like that before we even began? Okay, good. All right, number 2. Use the graph below to state the real roots, the zeros, the solutions, and the x-intercepts. Oh my gosh, is that 4 different things?
No,
Yeah, these are all the same thing, and you probably could circle these real roots. Let me use that since I have it. What did you circle? If you circled anything, or what would you circle? Okay, where it crosses the x-axis. And so that would be right here. Right here and right here. So my solutions are what? -1 and 3. Now, you had in your homework that was supposed to be due today, Jewels. In your homework that was supposed to be due today, we talked about some parabolas that had either an a value of +1 or -1. And then they asked you to put it in factored form. So I want you to write this down toward the bottom of your bell work. Factored form says y is equal to your a value times x minus r sub 1 and x minus r sub 2. Okay? Now, if my roots here are -1 and 3, because this is subtracting, okay, you need to think of the opposite. Okay? Kind of like opposite. So let's say I said that this a value here was equal to either +1 or -1. Which would it be in this case? Alexandra? Would my a value be +1 or -1 here? Thank you, Alexandra, the ventriloquist. Yes, it is +1 because it is opening up, right? So that's +1. When I substitute these roots in, right here, my solutions, my roots, my zeros, I'm going to get y equals 1 times, okay, it says x minus √1. Well, my root is a -1, and if I subtract a -1, it actually becomes x plus 1. Or what looks like a -1 is now a +1. And I say x minus √2, that is 3, so x minus 3. So this right here is factored form, okay? This is factored form. So let me do one more quick example, not even with the graph. Let me tell you that my solutions on the graph are at -8 and let's say -2. -8, -2, and they want you to write it in factored form. And let's say this time it is opening downward. And there's no compression, no stretch. Opening downward. Okay? Here's what you would do. You would say y equals, since it's opening downward, that's going to be -1 times x. Now, it looks like, and it is, a solution of -8. If you subtract a -8, it's going to look positive. So that is x plus 8. And my other one is x minus -2. It's a -2, but it's going to look positive because we are subtracting the root. All right? So that should help you with your homework. 12-3, okay? Oh, shoot. What's his name? Mr. Daisy? Mr. Daisy, Rowan. This should help you make corrections on that homework. So it is not in vertex form. You need to be putting it in factored form. And what looks like a -8 is going to be a factor of x plus 8. So that should help you with problems, I believe, 3, 4, and 5. Okay? So I am not collecting the homework today. I am making this due tomorrow so that we can fix this, because I feel like we didn't go over that enough. Any questions over that? All right. Now let's take out your notes. Take out your notes. That's the white part. White, what do you call that? Packet. And we are on section 12.4, solving quadratic equations by factoring. That's why we did a little bit of review of factoring, okay? But first, we're going to look at the square root property, all right? Okay, square root property. To solve a square root equation in the form of x squared equals n, take the square root of each side. Well, yeah, it's not quite that simple. I'm going to add a few steps here. I'm going to say first, isolate. What does isolate mean? Get it by itself, okay? Isolate the squared part. So get the squared part by itself. Then number 2, take the square root of both sides. Square root of both sides. And then number 3, make sure you have the positive and negative of the square roots. Now, this might not make sense to you now, but I will explain it here in just a bit. So first, isolate the squared part. If it's squared, it's going to say something to the second power. Take the square root of both sides and make sure you have a positive and negative of those square roots. So they show x squared equals 49. Is x squared isolated by itself on that side? Yes. So that checks off for A. Take the square root of both sides. So the square root of something squared is always that something by itself. So the square root of x squared is x. The square root of 3x, that quantity squared, is going to be 3x. Okay? I'm just making some of this up. And then when you take the square root of 49, yes, 7 times 7 equals 49, but you need to take both the positive and the negative values. Usually we just take the positive, but here we need to take both. Okay? So let's take a look at example 1. 1a. So I would ask you, x plus 7, that quantity squared, equals 25. Is the squared part isolated? Is it by itself? Yes, it is. Okay? So I am now going to take the square root and quantity x plus 7 and quantity squared. When you take the square root, those kind of cancel out, and I'm left with x plus 7 equals plus or minus 5. Because the square root of 25 is 5, but I also know negative 5 times negative 5 gives me 25. Okay? And this is where I am going to separate it into two different parts here. Okay? So this is kind of like absolute value, but not quite. So I'm going to say over here, x plus 7 equals the top part, positive 5. And over here, I'm going to say x plus 7, bless you, equals the negative 5. Okay? So I am going to subtract 7, because I'm trying to solve for x. My 7s will simplify out, and I get x equals negative 2. Or if I solve for the other side, subtract 7, x is equal to negative 12. Remember, these are quadratic, so this would be your two solutions where they would cross the x-axis. Okay? Any questions about that? Do you have the notes? The white packet? All right, let's take a look at B. 3x squared is equal to 27. Is the x squared isolated on one side of the equation? Was that a yes or a no? Yes. Is it? It looks to me, what's happening between 3 and x squared? It's being multiplied. So x squared isn't by itself. What do I need to do to get x squared isolated? Yeah, divide it by 3. So divide by 3, divide by 3. My 3 simplify out. X squared is equal to 9. Now my squared part is isolated. So take the square root, take the square root. The square root of anything squared is that anything. So x is equal to, and when you take the square root of a number, what number times itself gives you 9?
3.
3, and I have to talk about the positive and the negative. So you can leave it like this, or you can write it as x equals positive 3 or x equals negative 3. You can write it out like this. But there should be two answers. Okay? Any questions with this? Practice reading in the morning. Is that why you're kind of tired sometimes? All right. Really try to focus on this, okay? All right. Let's go to the next one. This one is similar to one we already did. Quantity y plus 5 and quantity squared equals 21. Is the squared part isolated? Survey says Yeah, it is. It says y plus 5, that thing is squared. So that whole thing is squared. That's the only part that's squared. It is by itself on that side. So let's take the square root. Take the square root. When you take the square root of something that is squared, you get that individual something. Y plus 5 equals, what is the square root of 21? Off the top of your head. Is there anything that works? 6 times 6, is that 21? 7? No.
It's not 4 or 5.
It's not a perfect square. So we are going to have to leave this as plus or minus the square root of 21. Now, I know when it comes to square roots, I'm still like it myself. I'm like, I don't even know what the square root of 21 is. I have no idea. But I know 4 times 4 is 16, which is smaller than 21. And 5 times 5 is 25. So I know it's between 4 and 5. Okay? But, like I said, 21 is not a perfect square. Leaving it in this radical form is more correct than writing a decimal. Because if you write a decimal, you'd have to round it off or something like that, which makes it not as accurate. But right here, I am going to separate this and say y plus 5 equals the positive square root of 21. Y plus 5 is equal to the negative part of the square root of 21. I want to get my variable by itself. So what would I do for this first equation? If I want to get y by itself, subtract 5 and subtract 5. 5's cancel out. Y is equal to, now because I have this negative 5 and I know how much that is, I'm going to put that first. I can't combine them, so it is negative 5 plus the square root of 21. That's my first answer. Or on the other side, you're still going to have to subtract 5, subtract 5. Y is equal to negative 5 minus the square root of 21. So, as messy as that looks, that is your answer. What questions do you have there? Fredderly. You know what? I'm not going to keep going around the room and every time say, get off your phone, get off your phone. You need some self-discipline. All right. So let's do the top of the next page. See if you can do that one on your own. So it's quantity. X minus 2, that quantity squared equals 16. This is called the square root property. Ask yourself first, self, is this squared part isolated? Okay, go on to the second part then, which is to take the square root of both sides. Take the square root of both sides. Okay, then you might have to break it down into 2 separate equations and solve. Let's see what you get. I better hold on to this or it'll stop recording.
I will come here tomorrow or Friday.
Oh.
Yeah, is there any work?
I will give you the homework, and if you can get on Canvas and look at the notes and try to watch the video, that will probably help. Pass this out to them tomorrow. Okay. Might not be totally done, but let's see how you did. So I was saying, is the squared part isolated? The answer is yes. It is one side by itself. So that means I can go ahead and take the square root of both sides. Whatever you do to one side, you have to do to the other. So then take that, and the square root of something squared gives you x minus 2. And we really don't need the parentheses anymore because we're not squaring anything. Equals, now what is the square root of 16? 4, but you need to put both the positive and the negative because negative 4 times negative 4 also gives you 16. Okay? This is where I would probably change it into two equations and say x minus 2 equals the positive 4 on the top and x minus 2 equals the negative 4. So then let's add 2, x is equal to 6, add 2, x is equal to negative 2. Those are your two options, x equals 6 or x equals negative 2. Any questions on that? Anybody get that? Both of them?
Yeah.
Nice. Okay. All right. So that's the square root property. All right. If you have an x squared, is it isolated by itself? If so, take the square root and see what you get. Now, I want you to box this little statement right here. I want you to put an asterisk, maybe 4, 3, something. Very important. Very important. Before you can solve an equation by factoring, the equation must be equal to 0. 0. All right, so again, we're back to factoring with quadratics. We have 4x squared minus 12x equals 0. We are solving by factoring or using the reverse distributive property. I call it reverse distributive property. As you look at that, do I have, actually, no, I'm not going to say that. What do we look for when we're factoring, when we have two terms? What do I do first? What do I do first? Come on, guys. Yeah, greatest common factor. Do I have one for these two terms? What? 4? So I can divide both of these by 4. Can I divide them by anything else? An x, too. Was that you? I was like, I heard it from over here. All right, so my greatest common factor is 4x. I'm going to put that out front, and I need to see what I need to have left in parentheses. So 4 divided by 4 is 1. What is x squared divided by x? Should give me a single x left, right? Minus 12 divided by 4 is 3. And x divided by x simplifies out. This is equal to 0. I have to include that 0 part. So I have two factors here. Think about it. If you have, and you are multiplying, who's the nurse? Oh, the nurse? I can't use one of these for the nurse. Yeah. Let me get, I have to get the one. If I have two factors and I multiply them to equal 0, what has to be true about one of those factors? If something times something gives you 0, what does one of those factors have to be? 0. Yeah, so we got to find out which one of these or both are 0. So you are going to set the first factor equal to 0 and say 4x equals 0. Then you set the second factor equal to 0. X minus 3 is equal to 0. Divide by 4, divide by 4, so we find out what our x is. X is equal to 0, or add 3, x is equal to 3. Those are your two solutions for that quadratic. Then it says to check. How would you check for these? Check. How would you check? Yes, substitute those values in. Go ahead and do that at your seats while I am taking care of business. Go on, you can do it. Come on. What's going on? Runny nose too? Or nose? Hope you get to feeling better. Okay, so if I am checking, it says check your solution. So if I do this function and substitute 0 in, I get 4 times 0 squared minus 12 times 0. Is that equal to 0? Well, 0 squared is 0. 4 times 0 is 0. 0 minus 0 is 0. Always work downward. 0. Is that equal to 0? Yes, it is. And you do it for the second one. X is equal to 3. We say we want the function when x is equal to 3. So we say 4 times 3 squared minus 12 times 3. Is that equal to 0? Do you have a pass? Now, order of operations. Thank you. Would I take 4 times 3? Or do I do the 3 squared first? Yes, 3 squared is 9. 9 times 4 is 36. 12 times 3 is 36. Is that equal to 0? Yes. Well, you need to work down. 0 equals 0. And that is your check. So if it says to check your solution, you need to be able to do that also. Okay? All right. We have time to go over one more together. Let's go over B. Wine. X squared minus 12x equals 0. I am factoring. What do I check for first? Greatest common factor, which is x. Divide by x. Well, you always say, Miss Thede, if you're going to do something in an equation, you have to do it to all sides. Well, yes, but 0 divided by anything is always going to be 0. So we really don't worry about this end part. That's why. So greatest common factor is x. Bring it out. X squared divided by x is x. Minus 12 has nothing to divide it by, so that's 12. And x divided by x simplifies to 1. So I get x times quantity, x minus 12 equals 0. Set each of these equal to 0. There's my first factor. Wow, that's my solution already. X equals 0. Or set the second one equal to 0. X minus 12 equals 0. Solve for x. And so x is equal to 12. Yes? I did not know that. All right.
I said rubberized cheese.
Wait, just a minute. So I want you to try to do A on your own, and then we'll call it a day. But I want you to be working on A. Ask yourself, self, do I have a GCF there? Okay, but do it to yourself. Work it. Work it. Work it. Gentlemen, you are not going to be sitting together if you guys don't chill a little bit, okay? Please don't do that. We're not that far yet. Are you like this in all your classes? Are you like this in all your classes? Or just your favorite ones like that? Oh, dear. Everybody should be working this problem. Try it? Did you do it already?